Your system block testing is quite a large chunk of your work, and it's going to lead on to everything else in the project. So this has to be correct, and it's more about getting your technique right so that you hit all of the marks in the mark scheme. It isn't a difficult thing, but you do need to understand that you are setting the parameters the same as you would in a science experiment. You are then saying, this is what I'm expecting to happen. These are any calculations I've needed to do, and this is the result of the test. And then on the whole, you need to know that each block is going to do what you're expecting it to do. And what you're expecting it to do is to respond to the input to the block. And the input might be a process block before it, or it might be an actual input component. And you've got to know what the output should be. And on the whole, if you refer to it as being either voltage high, voltage low, or logic high, logic low, then you're going to be working on the right lines. Because obviously, if you want the output from block B to be logic high so that it triggers the input to block C, which needs to be logic high to trigger it, you've got to make sure that they all match up. Within the marking scheme itself, you've got to name your block, you're testing what it has to do within the circuit. You have to set your parameters. So if there's anything pre-decided because of your specification, this is where you put it in. So, you know, if you're always using a 9-volt battery, you just put it at the beginning. Every test is going to be done for a 9-volt battery because that's what the specification said. You need to make sure that you record your results. So I'm suggesting that you produce a results table, 3 columns, specification point you want to test, how you're going to test it, and then somewhere to record your test results. If you need to do any calculations, so if you need to say how large your capacitors should be or how big your resistors should be, you do these calculations before you do the test because you're demonstrating your electronics knowledge. You are not supposed to be going, well, I'll put that size in and if it works on Circuit Wizard, brilliant, that'll do me. You need to actually show the calculations before you start. You then produce in your diagram on Circuit Wizard. Remember, it is just the diagram for the block. It's not the entire circuit. You need to make sure everything's labelled. You need to make sure that you've specified components. So if they're transistors, is it a BC548, a BC639, a 2N2222, whatever it is, have you actually specified it? You run the test, show your results, so screenshot your results, and then you put the results into the table and you write a conclusion. Now it might be at the end of the conclusion that your test has proved that your circuit does exactly the opposite of what you want it to do. In which case, how are you going to make it invert? How are you going to get it so you've got it the opposite way around? It might be that you just whack an inverter on there and that fixes the problem. It might be something different. So you would then, in your conclusion, say, look, this isn't doing what I want it to do because this, and this. So now to fix it, I'll need to do X, Y, Z, and then you put the solution, the modification, into your conclusion. Hopefully you won't need to do that very often. It can get a bit time consuming. Now the example that I've got on the screen here is showing the version that is in the exemplar material from the exam board. He's put down, it's his system development section, he's testing the subsystems. He's stated that it's a 9-volt battery here. He's stated that everything's been done on Circuit Wizard, so he's given his parameters. He's saying what the block that's going to be tested is, that it's the tilt switch, and what the function is. It gives a logic 1 when tilted beyond 10 degrees. They've listed that as adequate. But they're referring to the specification point, and this is where I said earlier, I think you need 9 specification points to actually successfully do each of the blocks of the block testings. So his tests were connected logic probe, switch to CMOS to the output, and check that what happened when he tilted the switch, which I would point out actually you can't do on Circuit Wizard. So yeah, don't write down something that isn't physically possible to be done on Circuit Wizard. They've put as an appropriate test. Query that one. Never mind. He would have to physically test this to work out the number of degrees for a tilt switch. There is no tilt switch on Circuit Wizard. He's given them the circuit diagram, and they've said, yep, it's a correct circuit diagram. His 33K resistor is a random resistor that is put in to act as a load, because if you had no load here, if you just had a wire going straight back, your output would list as 0 volts, which would be incorrect for an on-off switch. You have to have a load. In the case of the main circuit, it would be the rest of the circuit. In the case of this test, he's just put a resistor in. I did it for the line following thing, and I put a bulb in. I'm not really sure why he needs an earth contact here. He's got a battery. It's going back to ground anyway, so that seems a little bit surplus. But doesn't make it wrong, just makes it excessively complicated. The presentation of this can vary personally, because I love tables. I like to have stuff in tables, and then you can do copy and paste and only change the bits that matter. I would do it like this, and I would say what's the system block to be tested. That title can stay there on every one, and I just need to change this piece here, saying what the test is. The parameters for the test are going to be the same for every test, and it's going to be the fact it's 9 volts, it's going to be the fact it's on Circuit Wizard, it's going to be whatever else. If there are no relevant calculations, then fine, say there aren't any, not applicable. For this particular one, there were no calculations. You've then got your circuit diagram here, and then you've got the points you're testing. My circuit needs to run on a 9 volt power supply. The block output needs to give a logic high output to trigger the logic gate. I've tested it by, I've checked the voltage settings on the simulator, I've put a voltmeter between the output and the negative rail. One way of doing it. Circuit functioned correctly with the power volt side. The switch was open, the voltage was 0. When it was closed, this changed to 9. Now, I am going to slightly update this because I'm going to delete that. I'm going to go on to Circuit Wizard. So here was me testing it on Circuit Wizard. I drew it all out, but I've added a probe here rather than a voltmeter. Voltmeter would work just as well because I could have 2 images, but if we actually go for this as a slightly different system, if I press play on this, my switch is open, I've got my voltage levels showing here, and on my graph down here I've got my voltage as 0. When I close it, my voltage output goes there. When I open it, close it, open it, close it, and then if I pause it, I can then do a print screen from there. And actually that would be a far better diagram. Oh, don't do that. Far better diagram here.